Okay, so first question, second question. I have given you two questions. I hope my screen is visible. Yeah, just work out these two questions and then we'll get back about other things. Okay. So the first question, what is the remainder when this is divided by x plus 2? So because we want to try it with x plus 2, we want to find out p of minus 2. So p of minus 2 is minus 2 cubed plus 4 times minus 2 plus 2. So how much is this? This is 8 minus 8. This is minus 8 again plus 2. So this is minus 14. So the remainder when x cube plus 4x plus 2 is divided by x plus 2 is minus 14. Okay. Similarly, next the question is what is the remainder when this is divided by 2x plus 1? So this 2x plus 1 I can take 2 common and write it as x plus half. Because I can write it as x plus half, I will find out p of minus half. Yeah, so p of minus half. So the remainder will be same as when the polynomial is divided by if value of the polynomial at minus half. So I'll just rewrite the polynomial so that I can do it better. 4x cubed minus 3x square plus 5x plus 4 is divided by 2x plus 1. So I can say it is 2 times x plus half. So I try to find out p of minus half. So p of minus half is 4 into minus half the whole cubed minus 3 times minus half the whole square plus 5 times minus half and plus 4. So how much is this? This is 4 into minus 1 by 8 minus minus, so plus 3 by 4 minus 5 by 2 plus 4. So when I find this out, this is minus half. So this is 1 by 5, this is minus half will become 1. So this will become 3. So this will become 1. So 1 by 4 is like 7 by 4. So the remainder when this is divided by this will become equal to 7 by 4. Okay. So what we have done is we have used the remainder theorem here and then we have found out. Yeah. So I'll just be back. Yeah. Here is the first slide. Question is what is the remainder when this is divided by x plus 2? So we found out what is the remainder. Next question is what is the remainder when this is divided by 2x plus 1? Okay, so the second question I have done here, some of you are getting some different answer. Let me check if I made any mistake. I made a mistake. So this is minus 1 whole square, right? Whole square will be minus itself, the sign won't change. So it is minus 1 by 2 minus 3 by 4 minus 5 by 2 plus 4. So this minus half and 5 by 2 will make it 3, so that will 1. So it will become 1 minus 3 by 4, which will become equal to 1 by 4. Yeah, so this is minus 1 by 2 whole squared. Minus 1 by 2 whole squared will be plus 1 by 4. So this will look like minus 1 by 4. So here we have used the remainder theorem. We have used the remainder theorem and then we have worked it out. Yeah. Second sum, you want me to do it carefully again? Let me do it carefully again. So the question is 4x cubed minus 3x square plus 5x plus 4 is divided by 2x plus 1. Okay. So now 2x plus 1. So it will become 2 times x plus 1 by 2. So the remainder is same as when this is divided by okay, that is interesting. Okay, let me see. Okay, so we'll find out p of half. So we'll find out p of minus half and then we will check. So this is 4 into minus 1 by 2 whole power 3 minus 3 into minus 1 by 2 whole square plus so minus 5 by 2 plus 4. I don't agree with the numbers that you all are saying. So this will become 4 by 8. 2 cubed is 8. So minus 4 by 8. So that is minus 1 by 2. This will become minus 3 by 4. This is minus 5 by 2 plus 4. So minus half minus 5 by 2 is minus 3. Minus 3 plus 4 is 1. So I have 1 minus 3 by 4. So that is 1 by 4. So the numbers that you all are saying is wrong unless I have written the question wrong. Okay, so yeah, so okay, I got the question wrong then. That's fine, then it is fine. Sorry, yeah. So I wrote the question wrong. 4x cubed, the logic you all understand, right? So once you understand the logic, it is fine. So let us just do it final number. So it is 4x cubed minus 3x square plus 5x plus 1. 5x plus 1. Okay, fine. So it is divided by 2x plus 1. So I find out the value of p of minus half. So p of minus half, like we found out earlier, will give you minus 1 by 2. This will give you minus 3 by 4. This will give you minus 5 by 2 plus 1. So yeah, now what you are saying is correct. So this will become 3 minus 3. So it will become, so this is minus 3 plus 1, minus 2 minus 3 by 4. So that will give you minus 11 by 4. Yeah, so if you have written this question, this is the answer. For what I did, I got the answer, right? So the logic is fine. So I hope this one, all of you understand, right? Yeah. So few more questions we will work out. So the question is, what number must be added or subtracted to 3x square plus 5x, okay, so that it leaves a remainder 1 when divided by 2x plus 5. What number must be added or subtracted to 3x square plus 5x so that it leaves a remainder 1 when divided by 2x plus 5. Okay. 3x square, what number must be added or subtracted to 3x square plus 5x so that it leaves a remainder 1 when divided by 2x plus 5. So suppose we have to subtract some a. Okay, so we have 3x square plus 5x minus a is divided by 2x plus 5, and the remainder is 1, right? So what can I do? So I can take 2 common, it will become x plus 5 by 2. So I find out p of minus 5 by 2. So p of minus 5 by 2 is 3 into 25 by 4 minus 5 into 5 by 2 minus a. And this should give me 1 because the remainder is 1. So let's quickly work it out and see. So this is like 75 by 4 minus, this will become 50 by 4 minus a. So we have 25 by 4 plus 25 by 4. 25 by 4 minus a is equal to 1. So from there I'll say a is equal to 25 by 4 minus 1. So that is equal to 21 by 4. So you have to subtract 21 by 4. If you subtract 21 by 4, when you divide 3x square plus 5x, the remainder is 1. Yeah. So I hope you are able to understand. Yes, 21 by 4. Yeah. Others, please work out, quickly work out. Don't just wait for the teacher. Here's the question again. So here is the question. What number must be added or subtracted to 3x square plus 5x so that it leaves a remainder of 1 when divided by 2x plus 5? Okay, so here we are using the remainder theorem. As per the remainder theorem, p of some number will give us the remainder. So you see we have 3x square plus 5x. Suppose I have to add some quantity a, then we say that the remainder is 1 when divided by 2x plus 5. 2x plus 5 means what? X is equal to minus 5 by 2. So if x is minus 5 by 2, we can now find out. How do we find out? So we know that p of alpha should give us the remainder. So in this case, we are dividing it by 5 by 2. So I mean 2x plus 5. So I have to find out p of minus 5 by 2. So that will become 3 into minus 5 by 2 the whole square plus 5 into minus 5 by 2 plus a is equal to 1, because according to the question the remainder should be 1. So this will become 3 into 25 by 4 minus 25 by 2 plus a is equal to 1. I'll simplify this. So see, this is 75 by 4, this is 50 by 4. So it becomes 25 by 4 plus a is equal to 1. So I'll get a is equal to 1 minus 25 by 4. So that is minus 21 by 4. So what does this mean? This means that we have to subtract 21 by 4 and not add any number. Okay. Okay, so I am waiting for some indication. I will show you the 5th slide. Here is the 5th slide. Some of you are just copying, my dear friends. That is not allowed. We have to work it out. Okay, so if it is done, let me just check if there are any messages. Screen is lagging, understand sir, but screen is lagging. Others, I hope all of you are able to understand. We have done a lot of questions on factor theorem now and the remainder theorem. Now I have one small thing to discuss with you. Suppose there is some polynomial in x which is equal to a1 x power n plus a2 x power n minus 1 plus a3 x power n minus 3, sorry, n minus 2, and so on up to a n plus 1. Suppose we have a polynomial like this. Now suppose x minus 1 is a factor. Suppose x minus 1 is a factor of the polynomial. Then what can you conclude? You can conclude that p of 1 is equal to 0. That means a1 plus a2 plus a3 all the way up to a n plus 1 is equal to 0. So if you have any polynomial where the sum of coefficients is equal to 0, then such a polynomial is definitely divisible by x minus 1. Are we able to understand this? Yeah. suppose there is a polynomial p of x which is given this way. If x minus 1 is a factor of the given polynomial, then we know p of 1 is equal to 0. So if p of 1 is equal to 0, then a1 plus a2 plus a3 up to an plus 1 is equal to 0. So how do we know whether a polynomial is divisible by x minus 1 or not? If sum of coefficients is equal to 0, then the polynomial is divisible by x minus 1. Yeah. Similarly, suppose I want to find out if x plus 1 is a factor or not, then p of 1 must be equal to, p of y minus 1 must be equal to 0. That means suppose n is even. Suppose n is even, then I'll get a1 minus a2 plus a3 minus a4 plus a5 and so on is equal to 0. That means the sum of the odd coefficients, that is a1 plus a3 plus a5 and so on, must be equal to a2 plus a4 and so on. Only thing you have to be careful whether n is odd or even. Yeah, the only thing that you have to be careful is whether n is odd or even. Okay, can you make notes of these two? Yes, others. Sanjay. Yes, okay, good. Then who else is there? Lakshita, Indira, Divya. Martin. Okay, so if you guys are able to understand, few quick questions and then we move on from here. Okay, so here you have to tell me, find factors of, find at least one factor of x cube plus 13x square plus 32x plus 20. One. Second one is 3x cubed minus 4x square minus 13x minus 6. Then the third one is x cubed minus 5x plus 4. I want you to be able to tell me whether x plus 1 or x minus 1 are factors of the given polynomial or not. So if I have to check quickly, then what do I see? I see that in this case, the coefficient here is 1, coefficient here is 13, 32 and 20. So 1 plus 32 is equal to 13 plus 20. Yeah. So what does it mean? It means that this is divisible by x plus 1. Similarly, if you look at the third one, the sum of coefficients is equal to 0. Here you have 1 minus 5 plus 4. So sum of coefficients is 0. So if sum of coefficients is 0, what can you infer? It is divisible by x minus 1. Yeah. So if sum of alternate coefficients are equal to the other ones that we have left, it is divisible by x plus 1 and so on. So let's check here. So here I have plus 3 minus 13. So plus 3 and minus 13 is how much? 10. Here I have minus 4 and minus 6. That is also minus 10. So they are equal. So this is also divisible by x plus 1. So the first one is divisible by x plus 1. The second one is also divisible by x plus 1. The third one is divisible by x minus 1. So we can divide and find out what is the, yeah, so we can find out what we will get. Yeah, so are we able to understand? So let me just check. Yeah. Yeah, okay. Second question, x minus 1 is a factor or not? You are asking that. Okay, let us see. Let us see. Suppose x is equal to x minus 1. So x is equal to 1. So this will become 3 minus 4. No, x minus 1 is not a factor. X plus 1 is a factor. Second question, x plus 1 is a factor. X minus 1 is not a factor. Okay. Okay. Now I just have one more thing that I want to teach you guys. Have patience and let us focus. Okay. So I'll need all of you to focus a little and then understand. See, suppose I have some numbers like this. Suppose I have like 36, 54, and let me say 54, and let me say 108. Okay, I have 36, 54, and 108. I want to find out the HCF, okay, without factorization. Find out the HCF without factorization. What is the highest common factor of these numbers without factorization? Right. So see, there are multiple techniques. One way that you guys will do it is you will just do this, and that is factorization. So you will take two common. So this is 18, this is 27, this is 54. Then again you do this, you get 3 here. So 3 here, 6 here, 9 here, maybe 18 here. Then again you will do this, and then you will get 2, 3, 6. So the LCM, I mean the HCF is 9 into 2, 18. 18 is the HCF. Okay. There is yet another way of doing it. So before we go there, let's first understand what is this HCF. See, do you realize that HCF is one number, so that I can write 36 is equal to some constant into the HCF. Then 54 can also be written into some other constant plus the same HCF. Then 108 can also be written as some other constant into HCF. Now, when you subtract them, what will you get? You will get C minus B into HCF. When you subtract these two, what will you get? B minus A into HCF. So the HCF of these numbers is also equal to the HCF of the difference of numbers. Do you understand this concept? I am saying the HCF of the given numbers is also the HCF of the difference between numbers. I did B minus A, C minus B, I can do C minus A also. C minus A into HCF. Yeah. So this gives me another very important or useful technique to find out the HCF. Suppose I have 36, 54 and 108. I just subtract them. Here if I subtract, I'll get 18. Here if I subtract, I'll get 54. Right. Then again, if I subtract these two, I get 72. Now if I subtract these two, I'll get, and then I have my original number also. Now if I subtract these numbers, I'll get 18. If I subtract these numbers, I'll get 18. If I subtract these numbers, I'll get 18. So the HCF of the given set of numbers is equal to 18. So what did I do? I tried to keep subtracting those numbers with each other till I get the lowest possible number, yeah, other than 0. I will never get a lower possible number other than 18. So you can subtract them in any order, any way you want to subtract them. Any way you can subtract them. You will never get a number less than 18. So the HCF of the given set of numbers is 18. Do you understand this? And the logic is here. Yeah. So can you please write down and think about it first before you ask me any question? I'll just come back. ABCs are some constants. ABCs are some constant. We can do long division, but we want to do them fast. Yeah, ABCs are some constants. So I'll show you with another set of numbers, a smaller set of numbers, so that we'll understand it better. So maybe I'll take numbers like 36, let me take 48, and then let me take 72. Okay, I want to find out the HCF of these numbers. So I subtract these two, I'll get 12. I subtract these two, what did I get? I'll get 24. Then again I subtract any other numbers you subtract, 24. You subtract these two, you will get 36. Then I subtract these two, I'll get 12. I subtract these two, I'll get 12. Yeah, I can never get any number less than 12 when I subtract any combination of these numbers. Yeah, so the HCF of 36, 48 and 72 is 12. The logic I will explain again. So I can write 36, or the first number, let me say first number n1 is equal to some constant into the HCF. The second number will be some other constant into HCF. The third number will be some other constant into HCF. For example, 36 is 3 into 12, 48 is 4 into 12, 72 is 6 into 12. Okay, so now when I subtract them, I'll get 1 into 12. When I subtract them, I'll get 2 into 12. When I subtract these, I'll get 1 into 12. So that 1 into 12 will be the HCF. So when you subtract these two, you will get B minus C into HCF. When you subtract these two, you will get A minus B into HCF. So when you keep subtracting them, ultimately you will get HCF. You will never get any number less than that, because they are all three unique numbers. So this will never become equal to 0 unless you subtract it with itself. So that I'm saying either you will get 0 or the HCF. Yeah, I hope you are able to understand this. Now, if you understand this, we can move. If you have not understand name of this method is I don't know. I think some division. Sorry, subtraction. Yeah. So I hope all of you are able to understand this. Yes. If all of you are able to understand, then let me move ahead. So. Okay. So. Yeah, so understand this. Okay, I don't know whether this is really applicable or not, to what extent it will be applicable. I don't know, but yeah, I'll give you some questions based on this, so that we will try to find out. See, I am asking you, what is the HCF of, what is the HCF of x power 4 plus 3x cubed minus x minus 3 and x cubed plus x square minus 5x plus 3. The question is, what is the HCF of these two numbers? How will you find out the HCF of these two numbers? Okay. So the way I will do this is, I will simply take one and divide it by the other. If I take one and divide it by the other, see, all that I'm trying to say is this is equal to HCF into something. This is also equal to something, let us say A. This is equal to HCF into B. So okay, don't worry, just do this. Just do what I'm trying to tell you to do. Just take this and divide it by this. Let's see what you will get. So you will get x power 4, I mean x cubed. So take this and divide this. So I'll take a fresh one and then I'll divide. So I'll take like x cubed plus x square minus 5x plus 3, and I am dividing x power 4 plus 3x square minus x minus 3. So I'll put x here, so it will become x power 4 plus x square, sorry, plus x cubed minus 5x square minus 5x square plus 3x. Now when I subtract them, these two get cancelled. I'll get minus x cubed plus 8x square minus 4x minus 3. Now I'll have to divide this, right? So minus 1. So I'll get x cubed plus x square minus 5x plus 3. So again, I'm going to, it will not be minus, yeah, if it is minus 1, yeah, it will be minus, I'm sorry, minus, minus, minus. Again, I subtract them, this will get cancelled. So this will become 9x square, this will become minus 9x, this will become 0, yeah. So this will become 0. Now you see the degree of this is less than the degree of this. So I can say that x power 4 plus 3x square minus x minus 3 is equal to x minus 1 into x cube plus x square minus 5x plus 3 plus this much 9x square minus 9x. 9x square minus 9x. Okay, now, okay, so once you get this, no problem. Now take this and then divide it by this. Take this, divide it by this, keep doing that till you get zero remainder. That the last thing is the HCF of these two. I will explain again, don't worry. Right now you first do what I'm trying to tell you to do. Suppose they give you one polynomial P1x and another polynomial P2x, and they ask you to find out the HCF of them. What we are going to do is we are going to take P1x divided by P2x divided by P2x, assuming that the degree of P1 is more than the degree of P2. Now whatever you get the remainder, don't throw it away, take P2 and divide it by that remainder. Now whatever you get, take the first remainder divided by that. Keep doing this till you get zero. So the last quotient will be the HCF. So please do this once. I will explain again with some numbers. I will explain. Okay, so I will explain again. So see, there is a division technique. There is a division technique to find out the LCF of two numbers. So the same logic we are going to apply here. Suppose I want to find out the HCF of numbers 36, let us say 54, and let us say 108. Okay, so what I do is I take the smallest number and divide this by that. So 54 by 36. So the remainder is how much? Remainder is 18. Okay, now here 0, here 0. So 18 is going to be the HCF of the given numbers. This is same as the subtraction technique that we are using. Every time you subtract them, so this is same technique, same as the subtraction technique that you are using. 108 is divisible by 18. So the remainder is, so the HCF of these numbers is 18. Okay. Similarly, if you take x power 4 plus 3x cubed minus x minus 3 and divide it by x cubed plus x square minus 5x plus 3, then we will see, we want to find out the GCD of this. To find that out, so first is x here. So I have to be little careful. X power 4 plus x cubed minus 5x square plus 3x. Now I'm going to subtract them. When I subtract them, this vanishes. So here I'll get 2x cubed. Here I'll get plus 5x square. Here I will get minus 4x minus 3. Yeah. Then I will get plus 2 here. So that I'll get 2x cubed plus 2x square minus 10x plus 6. Now when I subtract them, this vanishes. This will be 3x square. This will become plus 6x. This will become minus 9. Okay. Now take this and divide it by 3x square plus 6x minus 9. Let us see what you will get. So like that you keep doing till you get zero remainder. The final quotient is the GCD of the given polynomials. GCD is the greatest common divisor. HCF is the highest common factor. Both are the same. So the greatest common divisor and the highest common factor are the same. Okay, so please keep doing this till you get it. So the next case, what I have to do is I have to take x cubed plus x square minus 5x plus 3 and divide it by this. So what do I do here? So I'll have 1/3 of x, so that will give me x cubed plus 2x square, then I'll get minus 3. So I'll subtract them. So here if it will become minus x square, then here if I subtract them, minus x square, then if I subtract them, this will become plus, so it will become plus 6. So minus 5x plus 6. So now when I find out, again I will get minus 1 by 3. If I do, I'll get minus x square, then I'll get minus 2x, then I'll get minus 3. So now when I subtract them, this will go, this will get plus, this will become plus. So I'll get minus 3x plus 3. Now minus 3x plus 3, I will take and divide. So this is so the next case what I will do is, here I'm getting this remainder. So now I'll take 3x square plus 6x minus 9 and divide it by minus 3x plus 3. So if I do this, now what will I get? I will just take minus x here. So I'll get minus 3x square, then I'll get minus 3x. So when I add them up, this subtract them, sorry, minus will be plus. Yeah, so when I subtract them, this will vanish. So this will become 9x minus 9. So I'll put here plus 3. So sorry, minus 3. I'll get plus 9x minus 9. Now I subtract, I get 0. So my final quotient was minus 3x plus 3. So this is the GCD of the given polynomials. Keep doing this till you get 0. Once you get 0, that final quotient is going to be the GCD of the given polynomials. So the question that we are trying to find out is what find the GCD of x power 4 plus 3x square minus x minus 3 and x cube plus x square minus 5x plus 3. Okay, so that is the question that we are trying to do. I am making some error in this is what I feel. Let me just look at it. X square plus Okay, so I'm making some small error in what I am doing it. I'm not making any error. I'm not able to explain it correctly. I have to take up one more example and then I have to explain. So the GCD is not this. The GCD basically comes from that last coefficient. So yeah, so the GCD comes from the last coefficient. So last remainder. So just wait, we'll do one more question and then I'll be able to explain it better. Okay, wait, let me try to put a small theory to this. Okay, so in the first step, suppose we have P of x, P1x and P2x as the two polynomials. So in the first step, what we are doing is we are taking P1x and we are dividing it by P2x, and the remainder is R1x. Okay, now what we are doing is we are taking P2x and dividing it by R1x. Suppose the remainder is R2x. Yeah, and then we keep doing this till we get zero remainder. So the remainder, yeah, so till we keep doing this till we get zero remainder. Now the remainder of the last but one step, remainder of the last but one step is the GCD. Okay, so the remainder of the last but one step, not the last step, last but one step. So in our case, what is the last but one step? The remainder of the last but one step, right? So in our case, this was the last step. Yeah. Ho, 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 ho. This is the, okay, let's do one more example. I'm sorry, I'm getting confused and I'm confusing you also. So let's do one more example and then we will check. Some of you have got it, you all have practiced it, you have got it. I have not. So I'm making some error. So let's please work this out. X cube minus 9x square plus 23x minus 15 and 4x square minus 16x plus 12. The question is find the GCD of these numbers. Find the GCD of these numbers. So please try to work out the way I said. Then we'll try to find out the remainder of the last but one step. And then let us say, by the time I'll just think and then get over. So please work out on this question. There is a question, find the GCD of x cube minus 9x square plus 23x minus 15 and 4x square minus 16x plus 12. Okay, so I will explain this one correctly. So see, you have 4x square minus 16x plus 12. So 4x square minus 16x plus 12 is being divided x cube minus 9x square plus 23x minus 15. So here is, okay, so here is x cubed, here is 4x square. So I'll write 1 by 4th of x, so that I get x cube minus, I will get 4x square plus I will get 3x. Okay, so now when I subtract them, this will vanish, this will become plus, this will become minus. So I'll get 5x square minus 20x minus 15. Yeah, now again I will do, so I will get plus 1, plus, this is 4x square, this is 5x square, right? So it will become 5 by 4. So it will become 5x square minus 20x minus 15. So there is no remainder here. So if there is no remainder here, this itself is the GCD between these two. Okay, so this itself is the GCD between these two. Now in the previous example, there is some error that we have made, so I'm getting it. So first you complete this one, then I will explain you the previous one so that we can complete it. See, this, when you divided it, the remainder was 0. Remainder is 0 means what? This number itself can divide this. So if this number itself can divide this, very clearly the GCD will be that the smaller number, smaller polynomial itself, the degree, the polynomial with the smaller degree. So 4x square minus 16x plus 12 is the GCD. Now in the first question, I have made some error. That's why I'm getting it wrong. So I have to just catch that error. So this is correct, 3x square. So I'm subtracting, this went off, 3x square, this becomes plus, so I'll get 16x, this becomes minus, so I'll get 9. So 3x square plus 6x minus 9. Yeah, then what did I do? Then I'll just go here and take x cube plus 3, plus x square minus 5x plus 3 is divided by 3x square plus 6x minus 9. 3x square plus 6x minus 9. So let me divide this. So here I'll first I'll have 1 by 3x. So when I have 1 by 3x, so I can say that this is equal to x cubed plus 2x square minus 3. Now when I plus subtract them, I'll get minus 2 minus x square, then I'll get minus 5x plus 6, right? So then I am going to work with this again, and I will say minus 1 by 3, then I'll get minus x square minus 2x plus 3. So now when I work with it, plus, this will become plus, this will become minus. So I have minus 3x plus 3. Okay, so now I can write this as minus 3x minus 1. Yeah, now understand that this can divide this, right? So you have to keep taking it till that step where, this is where we made the mistake. So 3x square plus 6x minus 9 is divisible by x minus 1. Okay, now because it is divisible by x minus 1, this is going to be the factor of the given polynomial. Yeah, so this is going to be the factor. So you take out 3 there, so it becomes x square plus 2x minus 3. So this is going to be the greatest common divisor for the two polynomials. X square plus 2x minus 3 will be the GCD for the given polynomial. That means you keep doing this till you get the step where the previous quotient is divisible by the remainder. If this quotient is divisible by the remainder, so this is divisible by the remainder, then the quotient of the previous, the divisor of the previous step is the GCD. So the divisor of the previous step is this. So that will give you the GCD. So 3 into x square plus 2x minus 3. So that x square plus 2x minus 3 will give you the GCD of the given situation. Okay. So I don't know, I might have confused you. I will, yeah, this doesn't matter. The question is, what is the GCD? So the GCD is going to be equal to, in the second example, so in the second example, the GCD will be the number itself, the fraction itself. So in this case, see, in this case, when we are dividing this by one by the other, there is no LCM left, right? So this itself is the GCD. There is no error in this. I have done carefully enough. There is no error in this. This is 100% correct. In the previous one, I had made an error. I have rectified it. Okay. This is slightly confusing. Next class, we will do a few more questions on GCDs and then we will progress. But I hope the rest of the factor theorem, factorization and other things are learnt. Okay. Okay, good, fine. Thank you. Next class, we will work more questions.